this Love Data session, and the next hour is being brought to you by the Arts and Humanities Institute here in Maynooth University. And we're going to talk about two things. It's in two segments, if you like, which reflect the research project we're engaged in. And basically what we're doing is we're looking at historical populations, large ones, and we're trying to make some digital sense of them so that we can obviously investigate them, but also ask our research questions, which we have always had, and also frame new research questions. So that's brought us a long way. And one of the areas we're very anxious to develop, and we have been developing, is the area of digital mapping. What I mean by that is the digitizing of historical maps and using them or leveraging them with prosopographical or biographical and other data to produce really versatile and high performance tools for historical research, for sociological research, and for other pursuits, the arts, humanities, social sciences, and then the sciences in general. So our first presentation today is delivered by Stavros Angelis, who is Senior Technical Officer here in the Arts and Humanities Institute. And he will introduce himself, but he's got a very strong background in information science and has worked on many humanities projects like ours. And he's going to be looking today at digitizing a historical map. So I'll hand it over to you, Stavros. Thank you.
Hello, everyone. Let me share my screen. Thank you for having us. I'm Stavros Angelis, Senior Technical Officer here in the Arts and Humanities Institute. And I'm going to speak to you today about the steps involved in digitizing a historical map. Now, I will keep it on the practical level. I won't speak about the theory involved a lot, just some basic things that you would need to know to understand what's what. So let's dive into it. Now, a quick walk through the process of digitizing a historical map and of this presentation. So we will speak about what does digitizing a physical map means and why would we want to do that. We will speak briefly about what is GIS and what is QGIS, what is georeferencing and how can georeferencing be performed with QGIS, and we will demonstrate some of the potential outputs. Let's start with what is digitization. Digitization is the process of converting physical objects into a digital format. This means that we can create a digital copy of a physical object by using some specialized equipment, for example, book scanners, digital cameras, phone cameras, and many more. Now, on the left here, you can see a typical book scanner, often employed by libraries to digitize books. And on the right is our own overhead scanner here in the Arts and Humanities Institute, which we have used to digitize various things. The equipment can vary from very basic, like a phone camera, to advanced and highly sophisticated, like this book scanner or very advanced versions of this book scanner. Depending on the result we aim for, there are several things to consider. For example, the lighting conditions are important, and the settings, the expected resolution, perhaps ambient noise for audiovisual files, the output file format, technical metadata, and many more. The case of maps can be quite challenging due to the size of the physical object, the physical map, the condition of the object, and other parameters. For example, physical maps are rather large. Most scanners cannot handle items of that size, so we need to use other techniques for the digitization process. For example, if we were to use this overhead scanner we have, then we would need to put the map on the bed, on this bed here, and photograph it in pieces. And then we would use a dedicated software to stitch the pieces together. Other techniques might involve putting the map on the ground and using a high quality photographic camera from a high altitude to photograph the entire thing. That sometimes is not possible, but it depends on the actual result we want to have and the means we have at our disposal. The primary source used for this little project is called the Survey of the Estates of the Right Honorable Benjamin Lieutenant Baron Bloomfield in the Kings County and County of Tipperary. It was created by Sampson Carter, civil engineer, in 1836. This source was digitized by our colleagues here in the library and was kindly supplied to us. I haven't seen the physical source, and I'm not certain about the actual dimensions, but I assume it is in book form. Our colleagues from the library should know more about the exact process they used to digitize the book, but I can tell you about the results. So the digital outputs are high quality and resolution images, 600 points per inch, and they're stored in lossless TIFF file format, which is lossless means that the information is not compressed, and therefore the file size is very big. And it's suitable to, these kind of files are suitable for all sorts of applications because you can change them into something smaller if you want to publish them and have a limitation of space. But the actual file is large enough to keep all the necessary detail for all sorts of applications. For this little project, we used page 3, which is this one. We had to prepare the page somehow for our project. So in what I'm going to present to you, we have used these two separate areas. And in order to use them, we had to cut them out of the picture and separate them. Let's speak about georeference a little bit. So georeferencing means that the internal coordinate system of a digital map can be related to a ground system of geographic coordinates. Let's assume that the digital map contains a set of coordinates, meaning a set of points in space. These internal map coordinates are related to a known ground standard system of geographic coordinates. That's georeferencing. A georeferenced digital image or map has been associated to a known Earth coordinate reference system, so users can determine where every point on the map is located on the Earth's surface. A coordinates reference system is a framework used to precisely measure locations on the surface of the Earth as coordinates. In this way, we start from a flat digital map. This flat digital map can be projected as part of the spherical Earth, and people using the map can determine where everything is located. It would be great if the flat earthers were right. We wouldn't need to do any of these things, but since they're not, and the Earth is spherical and it has different altitudes and all that, we need to have some techniques in order to properly project locations on a map. Georeferencing in the digital file allows basic map analysis to be done, such as pointing and clicking on the map to determine the coordinates of a point, to calculate distances and areas, and to determine other informations. So what is GIS? GIS stands for Geographic Information System. It is a computer system that analyzes and displays geographically referenced information. It uses data that is attached to a unique location. In short, it is an information system used to store and analyze geographically referenced information. QGIS now is a piece of software. It is a free, open source geographic information system. With it, users can create, edit, visualize, analyze, and publish geospatial information. It comes as a desktop application for all major operating systems like Windows, Mac, Linux, and it has a very big community that supports it. The current version is very robust and user-friendly, so it can be used without any fear for all sorts of projects. A server application and a web client are also available, but we won't focus on those today. QGIS supports scripting in Python and R for more advanced users, meaning that if someone knows how to use these scripting languages, they can do advanced things without using the graphic interface. Documentation and user guide manuals are available, and you can get those from the official website of QGIS, but at the same time, since there is such a big community, the web is full of articles for all odd cases one might come up while working with QGIS. You can find YouTube videos explaining things, and so while working with QGIS, people won't find themselves lost. The steps involved with digitizing a physical map in QGIS are the following. First, we create a new project. Then we import OpenStreetMap as a base layer. OpenStreetMap is a free editable map of the whole world that is being built by volunteers largely from scratch and released with an open content license. What that means is that we have a projection of the Earth that we can use as, let's say, an underlying layer of whatever we're trying to build. And this layer is free to use and reuse, free to edit, and we can do whatever we want to do with it in our project. It's always a good idea, though, to reference that that's what we use, so that we do the right thing with the people that have created it. Then we import the digital map and georeference it. We digitize the map features. By map features, we mean, for example, estates, townlands, so polygons in this case, roads, rivers, buildings, whatever is of interest to us. And finally, we can analyze the data in QGIS or export the data in various forms and use them for other applications. Now we will go through the steps we need to actually digitize the map. So the first very simple step is to create a new project in QGIS. It's as simple as clicking on project new and then saving the project somewhere. Now it's always a good idea to create a dedicated directory structure for the project because the more work we are doing, the more little files are produced. And so it's a good idea to, from the start, to have everything under a certain structure, otherwise we will get lost. So then we need to import the OpenStreetMap. As you can see here from the main navigation bar of QGIS, we select the Open Data Source Manager, which is this window here. And in this window, we select from the left-hand side bar XYZ connections, which brings us to this screen. And there is a drop-down list here where we select OpenStreetMap and click Add. It's as simple as that. And this brings us to this interface. Now, this is the entire QGIS interface. I'm not going to go through all the little buttons here, but I'm just going to say that this is the main area here where you can see the outputs of what you're doing, and this is the list of layers. So in this case, we just introduce the OpenStreetMap layer, and we can see it on the main part of the screen. Then the next step is to import the digital map image to the Georeferencer tool. In order to open the tool, we select Layer and Georeferencer, and we will have this new window opening up. In this window, we select Open Raster, which is this little icon here, and that opens up a file explorer in our computer, and we locate the digital copy of the map we have, and we select Open. And this will import the digital file into the tool, which would look like that. So now we want to georeference the image. To georeference the image, we select points on the image and associate them with known coordinates on the OpenStreetMap. There is a number of ways to perform this task. In my opinion, the easiest is the following. We first start with the Add Point tool, which is this little icon here. And this opens up this pop-up window you see here. Now, then we click on the image somewhere, like for example, this little green dot. I don't know if it's visible in your screens. And then we click from map canvas, and that would bring us back to this. And we click on any location here. And as soon as we click on that location, these two inputs will be filled in with the coordinates, and we click OK. Similarly, we add more points. As you can see here, we have various red points, and they all appear as an editable list underneath. If we make a mistake, we simply remove the location. It's as simple as that. So once we always try to have as many points as we can, but we have to be rather confident that they are correct. Sorry about that. And we try to get the edge cases, as many edge cases as we can. That will help with making the image appropriate for the map when we import it. But it's also always helpful to get some middle points as well. Now, this process has some difficulties that we always need to keep in mind. The main obstacle is to identify where the depicted location would be on a modern map. Since we're dealing with historical locations, that might not be that simple. That is where domain expertise is necessary. We could also use tools like the townlands.ie, but keep in mind that when we're dealing with historical maps, that might not be that helpful, because boundaries change for locations, location names change, or their spellings change, some things move a little bit. So I mean, in my opinion, the most helpful is to have a domain expert close to you while at least starting this work, so that you know that you're in the right location. The final step to import the georeferenced image into the map is to set the transformation settings. By transformation, I mean, if you see here, the image has been distorted. You can see that this is not a straight line, and there have been some changes. Now, this is the image we had initially, and this is the image that went into the map. In order to get a good result, we need to set the transformation settings here. The first thing we need to set is the transformation type. QGIS comes with a list of built-in transformation algorithms that we can use. What these algorithms, is that they are trying to translate the various points we have selected they're trying to adjust the image we had to the new locations so that it will appear correctly on the screen. A trial and error would help you select the appropriate transformation type. In our case here, thin plate spline was the most appropriate one. The second option is the target coordinate reference system. In this case, we're using what you see on the screen because it is the one that the underlying OpenStreetMap is using, and we need to use the same one. Then we select where we want to store the actual image file in our computer. And again, we just click on these three dots, and the Windows Explorer opens up. We select the directory and save it. And finally, we need to have these two checked. This one means that this image will have some transparency. If we don't select that, as you can see here, it has a curve. If we don't have that checked, this will be a black area, which is not good. And then we have selected loading project when done, and we click OK. And this, what you see on the right here, is the result. Now, to digitize the map features, we first need to create a shapefile layer. It's as simple as selecting create layer, new shapefile layer. And then we need to fill in a few information. So first we select again, a place where we want to store the shape file in our computer. Then we set things to UTF-8 because we might have strange characters like Greek characters, Irish characters, or whatever, and UTF-8 supports that. We select the geometry type. In this case, we were trying to georeference townlands. So we were actually creating polygons. We select the coordinate reference system, which, as I told you before, is the same as the OpenStreetMap. And we add a few fields that correspond to the information we are trying to capture. So in this case, we're trying to capture a label for each polygon and the type, because we might have more than one types. Now, to digitize the map features, this is a very simple process with the shapefile layer selected. First of all, let me say that I'm going to show this to you in more detail inside QGIS. That was not something that could easily be put on a slide, so I'm just keeping the menus here for your reference, but I will show you exactly how this works later on. To digitize the map features, we select the shapefile layer and we click this little pencil icon here to make it editable. Then we select this icon here, which is the add polygon feature, and we go around the map, click on the various points around the polygon, and that's how we create the polygon. So as an example, this is the, on the left, this is the OpenStreetMap. You can see the various points we used to georeference our image. Then this is how our image looks inside the on top of the OpenStreetMap, inside the map. And these are polygons. So what we did was we used the image and we started going around clicking for each one and saving each one. And now you can see just the polygons without the image on top of the map. And the shapefiles also contain the information we used. So you can see that we have a list of all the townlands we've identified. And we have a label and a townland, and we can select them and they will be highlighted on the map. So let me switch my screen and go to QGIS, which would be this one. Do you see this screen?
Yes, you can see that.
Okay, perfect. So this is the actual project in QGIS. This is the main OpenStreetMap layer. And while working with it, I have created a few more layers. The first layer is one of the images. Let's zoom to that. So you can see it, it's here. And if you want to see where that is in Ireland, it's around here. Let's zoom back to it. Now we have identified the locations, and now you can see them here. So you can see how this works. I've selected this kind of dotted representation to make it simpler for me to see them while creating the polygons on the map image. But this is something we can easily change. For example, we could make it like this or like this. There are many options. So we have a list of attributes, but let's see. I don't think you can see the attribute table, but at least you can see how the selection works. Because of the files of the screen sharing, this is on a new window, so I don't think you can see that. But that means that we more or less have a database here as well. Okay, and let's see. Then we have the other one that I did, which is here. You can see how greatly distorted the image is down here. If we zoom in more, it is clearer. Don't think that, because it looks kind of distorted here. Yeah, you can see that it is clear enough. And then you can see the other locations. Now, if let's say we had a new polygon we wanted to add here, we would first select the save file. We would click on the pencil to make it editable. We would select the polygon tool, and then we would create a new polygon. We can give whatever shape we want. And then we would store it as, let's say, a new polygon. And now you see we have a new polygon. Now, even if we did a mistake while creating this, that's not a problem, because there are other tools that allow us to fine-tune the polygon however we want, which gives us the freedom to manipulate the new polygons and make them as detailed as we want. I mean, see here how nicely we follow the borders. Now, we can do many things with this data set here in QGIS. Like we can measure distances. We can, if we have roads, if we decided to also digitize the roads, we would be able to measure things like how long it takes someone to go from point A to point B by using the roads. But I think that it's more interesting to show you a very small application that I quickly built using the export of this data set. So let me switch again. Now, this is a web application. It's entirely web. We have the layers here. And so in this way, we could easily publish our collection to the web and add it to whatever website we have. And we can add all sorts of interactions. This is very basic. But let's say, for example, we have information about this. We can also attach this information, this information was kindly provided to us by Kieran Riley, our colleague. So we can do all sorts of things. We could add a search function here so that people could go to its townland. We could add the time dimension, the time slider, which would, depending on the time, would show on the map the appropriate map layers. And of course, people would be able to just see the features without the map. So as you can see, the underlying borders more or less align. So many townlands are similar to where they used to be. Others have slightly changed. This is something that we can easily see. So there are many, many things we can do when we get our data to this point. That's it from me. We can have we can have some questions now, or we can leave it for the end after the second presentation, whatever you prefer.
Has anyone any questions for the moment? I don't see any in chat at the moment, Stavros.
Yeah, one question, Stavros, and thank you. That was just a brilliant presentation. When you were making the move from, so you have digitized the estate map, you have the OpenStreetBase map open, and now you're going to find on the street map where the estate map is located. And you said that's a tricky thing because you need domain knowledge. So in that case, Stavros, would say knowing the names of some of the townlands in the estate map, would that be a help then for locating the estate map on the street map base? Or would you need something more than that?
In this case, most of the names changed.
Yeah.
So today they are different than what they were on the digitized map. So that wasn't very helpful. Mm-hmm. I had to ballpark, find a similarly named townland, and then work from there.
Okay. But generally, it's that sort of information. It's the name of a geographical point, which will identify where on the base map the estate map is, the digitized estate map. Okay, that's great. Thank you. Thank you. That's very clear.